Hi, this is Prasanna from Wave Academia. In this video, we're going to see how to develop boost converter model using Matlab Simulink. What is boost converter? This is nothing but a DC-DC converter which will convert low level voltage to high level voltage. As the name itself suggests that it will boost the voltage. Output voltage will be always higher than the input voltage. Let us see how to simulate this thing. This one. I'm just away. I took one Matlab program. So for the development of DC-DC boost converter, I need some components. I'm going to library browser. I'm going to Simscape, electrical, specialized power systems. Under that I'm going to sources. I need a DC voltage source. This will be my input. I need a diode. I need a switch. And then I'm going to passives. I'm going to take series RLC branch, one for my boost inductor, one for the capacitor and one for the load. That's all. I will arrange the elements one by one first. So if you take this component, it's a combination of series RLC. I need only inductor. So double click it, select only inductor. Similarly, you do all the component. Here I need only the capacitor. And in this component, I need only the resistor that will act my load. Okay, just take this. This one is my switch. This switch is having 4 ports. Actually, M is not a port actually. I don't want this M port. Double click it, disable the measurement port. That port is available only for the measurement of current through the switch, voltage across the switch, those things you can see. As of now, I don't want that one. Similarly, if you take diode, I don't want M port, I'm disabling it. I can say this one is my inductor. So as per the circuit, the inductor will come into the input side of my circuit. After that, diode will place. In between that, there's a switch. I'm going to connect my capacitor as well as load in which parallel to the input. So here I want to measure my input voltage as well as output voltage, and moreover I want to measure the current through the inductor. So I need a component called voltage measurement as well as current measurement. One is for measuring the input voltage, so I am connecting the voltage measurement in parallel with the input source. One measurement in parallel with the load. Similarly, I want to measure the current through the inductor, so I'm disconnect this line here. I need a current measurement. We normally measure the current in series with the element. Now, if you want to see the output, then you can go with scope. I want to compare my input as well as output. So I'm fixing in scope, it's having two terminals. One is for input and another one is for my output. Okay, here this is nothing but your switch actually. Okay, if you want to control the switch, you have to go with a gate pulse. So for that I'm using pulse generator. This one is pulse generator. I'm flipping it. You can directly connect it here. So this generator will give you the output of pulse that will make this switch on and off accordingly. So I need a power guy. Power guy is mandatory whenever you are working with the Simscape elements. Okay. So now I'm going to give the inputs. Let it be my input voltage is 12 volts and the inductor value, let it be 47 millihenry. 47 e power minus 3 millihenry, and the capacitor value I'm going to fix it as 100 microfarad. These are all the designed values. Load I'm going to fix it as 100 ohms. So in pulse generator I have to give my duty value to make the switch on and off as well as switching frequency. So here let it be amplitude is 1, period I'm giving that 2 e power minus 5. So what 2 e power minus 5 says? We know that frequency is nothing but 1 divided by t. So here this 2 e power minus 5 represents the time. So what will be the frequency? 1 divided by 2 e power minus 5, which will give you 50 kilohertz. So 50 kilohertz is the switching frequency of this DC-DC boost converter. Okay, so here the time, the period indirectly represents the switching frequency. Here I'm going to fix my duty ratio as 60%. That means the duty value is 0.6. Applying it. Now if you run the program, switch value, diode values and all, let it be as it is, no need to change. If you execute the program, If you want to see the output in clear manner, I will change the background. Let it be 2. This one is black. I'll fix the second voltage. Actually, second is nothing but it's a output voltage. For output voltage, I'll fix red as red color. Okay. Now, if you look at this, this is your input voltage. That was 12 volts, whereas this is your output voltage. It comes around 29 volts. So now the input voltage is boosted to higher output. The output voltage is always higher than input voltage in boost converter. Similarly, if you want to look at the output of current through the inductor, you can use this one. So this is the current through the inductor. Suppose if you change the duty value, instead of 60%, say 80%, apply it, okay, run it. Now if you look at the output, so depends on the duty value, your output may vary. So now previous value was 29 volts. Now you are getting around 59 volts. So based on the duty value, the output may vary. So this kind of study you can do with the help of this simulation. Here, instead of this pulse generator, you can use PWM Dcdc generator also, that I will show you how to do that. So this one is PWM Dcdc generator, which will generate the PWM. If you look at this, if you double click this, you can see switching frequency is directly given. So previously in pulse generator, you can give the switching frequency in terms of time period. Here you can straight away give the switching frequency. Let it be the same switching frequency as 50,000 Hertz, that is 5 kilohertz. Here you have to give the duty value. How to give the duty value? You can use constant. Say the constant value is 0.6. 0.6 nothing but your duty value, 60%. If you connect it, you can simply connect it here. This will also work in the same manner. Look at this. You will get the same kind of output. Black one is your input voltage, whereas red one is your output voltage. We can able to see here some initial transients will be there. So initial transients and all, it's an unavoidable one in power electronic devices. Okay, but the settle time, it will be very actually low. Within 0.1 seconds, the transients will be get settled down. But it's unavoidable in electronic circuits. Okay, so you can use the boost converter with the help of pulse generator as well as PWM generator also. Hope this video will help you to develop the DC-DC boost converter. In upcoming videos, we'll look at how to develop the closed loop boost converter. Okay, thank you. Please subscribe the channel.